Hello students, how are you? I welcome you all into this Jaswal Edu Maths. Today we are going to learn the topics of next topic in matrices and the minor and cofactors. Okay, so minor and cofactors. So in the previous videos, I have explained you how you can find the determinant of matrices. Okay. Now, when we talk about minor of matrix, minor is actually here you have to first understand what is A. A is a matrix, and it is not of any order. It is a square matrix of order n. Okay, is a square matrix of order n. So this is called the. If you want to find the minor first, so Mij is denoted as minor, okay, and I denotes that number of rows, and J denotes its column. So actually it gives the information here where is the element M12, like suppose Mij. So if it is saying that find the element M12, so where would you find? You would go to the first row and second column, okay, and find the intersection, first row and second column, like this. If you find the intersection like this here, then this would be the location of the particular element. So I and J, it gives you the perfect location, okay. So you would understand it in the that means practical question. So we are talking about the Mij. What is this? So this would be minor of the determinant of a square matrix of order n minus 1. It is a determinant of square submatrix of order n minus 1. So now you have to understand this concept with the example. Okay, so how would you get this? So suppose we have, okay, A equal to A11, A12, okay, A13, A21, A22, A23, A31, A32, A33. Okay, so here I have told you that A is the matrix of square matrix of order n. So the order of this matrix is 3 because it is square matrix of order 3. That means 3 cross 3. It has 3 rows and 3 columns. Okay. So I want to find the M11 first. Okay. So it is the determinant of the square matrix, square submatrix of order n minus 1. Means if you want to find it, you have to find the determinant. That means like if you want to find M11, all right, M11, so it would be determinant an order n minus 1. That means if it is 3, if it has order 3, then determinant that the minor should have order n minus 1. That means 3 minus 1, 2. Okay, so you would get 2 cross 2 matrix always here. Your minor would be in 2 cross 2 matrix, and here you see that it would be determinant of a square submatrix. Means you have to leave first row and first column. Okay, leave first row and first column. So what would you get here? You get A22, A23, A32, A33. Okay, so what is this? This is the determinant of square submatrix. So it is submatrix Okay, A22, A23, A32 and A33, it is a submatrix. Okay, submatrix, and you are taking the determinant of this submatrix. Okay, this is the sign of determinant, and it has order n minus 1 means it has order 3 cross 3, so it would have order what 2 cross 2. Are you getting? So let's do with m12. What would you do with what is the value of m12, or what would it be? So m12 would be when you leave first row and second column. So leave first row and second column, so we'd get here A21, A23, A21, A23 and A31, A33. Okay, A31, A33. Now talk about M13. Okay, similarly we have to remove what, first row and third column. So whatever you get here, it would be your M13, and you have to take what, the determinant. So it would be A21, A22, A31, A32, and similarly you would find M21, M22, M23, M31, M32, M33. Similarly you find. Okay, this is the procedure. If you want to find M22, you have to remove what, second row and second column. If you remove second row and second column, what would you get? You get the element A11 and A31, A13 and A33. So I hope you will do like this. So okay, what is cofactor now? You've understood how you can find your minor, and we'll understand it in a better way with an example. But what is cofactor? So cofactor is minus 1 raised to power I plus j. It is a multiple of mij, minus 1 time minus 1 raised to power I plus j times mij. Okay, it is, cofactor is minus 1 raised to power I plus j times mij represents here minor. Okay, and here again you have A is the same, Aij is the matrix of order, a square matrix of order n. Okay, so you need to learn this. And what is adjoint of A? Okay, so adjoint is actually transpose of cofactors. Okay, cofactors. And how you find the A inverse? A inverse you find adjoint A upon determinant of A. And here determinant of A should be not equal to 0, means it should be non-singular. So write down all these, learn it. We'll use the application in the question. So before doing this, we should do, I think, one question. Okay, then we'll do the. So how would you find minor and cofactor? So this is A is a matrix A0 2 2 5 4 3 0 3. Okay, this is a square matrix of order 3. All right, and you need to find the cofactor. Okay, and adjoint, we'll find also the adjoint. So how would you find? First you have to find the minor. So how would you find it? So minor first, minor. So you find here M11, M12, okay, M12, sorry, you can write M13, here M21, M22, M23, right, M31, M32, M33. And how would you get this minor? Remove first row and first column, so you get 5 4 0 3, and you need to take the determinant of submatrix here 5 4 0 3. All right, remove first row, second column, you will get 0 2 0 3, 0 2 0 3. Okay, remove first row and second column. First row in this M13, first row and third column, what would get? 0 2 5 4, 0 2 5 4. All right, solve it first. Left cross minus right cross, 15 minus 0, it is 15. Left cross minus right cross, 0 minus 0, it is 0. Left cross minus right cross, 4 0 minus 10, it is minus 10. Again, find M21. How would you find it? M21, second row and first column. Okay, second row and first column. 2 4 3 3, 2 4 3 3. Okay, second row and first column. Second row, oh sorry, I forgot also. Second row and first column, sorry, second row and first column, 2 4 3 3. All right, second, now M22, second row and second column, 1 3 2 3, 1 3 2 3. Okay, second row and third column, 1 2 2 4, 1 2 2 4, second and third column. Now solve this also. So left cross minus right cross, 6 minus 12, it would be minus 6. Left cross minus right cross, 3 minus 6. Okay, it would be minus 3 again. No, not again, sorry. Left cross minus right cross, 4 minus 4, it is 0. Now M31, third row, remove third row and first column, you would get here 2 5 3 0, 2 5 3 0. Okay, solve this. Left cross minus right cross, 0 minus 15, it is minus 15. Okay, and what about this M32, third row and second column, 1 0 3 0, 1 0 3 0. And M33, remove third row and third column, 1 0 2 5, you get 1 0 2 5. So left cross minus right cross, 0 minus 0, you'd get 0. Here left cross minus right cross, 5 and 5 minus 0, it is 5. All right, so here you'd get here, when you arrange this, okay, the 15 0 minus 10 minus 6 minus 3 0. Okay, so it is your what, the minor. Okay, and how would you find the cofactors? So cofactors would be, I told you that this is the minor, you can write here. How would you write here? You can say the minor m equal to, here you would write here 15 what, 15 0 minus 10 minus 6 minus 3 0. Okay, and minus 15 0 5. This is your minor. Okay, yeah, 15 0 minus 10, yeah, we have 6. Now this is your minor, and what do you have to do now? remove it first. Okay, we have to do also find, we have to find also the cofactors. Okay, so according to the definition of cofactors, what is this? Cofactor Cij is actually is the multiple of minus 1 raised to power I plus j and minor. Okay, all right. So here we have, if you want to find here, suppose this is C, okay, and C11, C12, C13, cofactor C, okay, these are the elements, C21, C22, C23, C31, C32, C33. So how would you find the answer? The answer would be here, it is minus 1 raised to power this minor. So this I plus C11 is minus 1 raised to power I plus j, this is 1 plus 1, okay, and your minor M11, okay, 15, all right. So okay, and C12 minus 1 raised to power 1 plus 2, okay, I plus j, and your M12 is what? 0, all right. C13 is minus 1 raised to power 1 plus 3, and then M13, okay, M13, what is your M13? Minus 10, okay. C21 is minus 1 raised to power 2 plus 1, and M21, it is minus 6, and minus 1 raised to power again 2 plus 2, and it is minus 3, okay, and minus 1 raised to power 2 plus 3, 0, okay, minus 1 raised to power I plus j, what is 3 plus 1, and your M31 is minus 15, again minus 1 raised to power 3 plus 2 into 0, and minus 1 raised to power 3 plus 3 into 5, okay. So what do you see here? You see that even power of minus 1, odd power of minus 1, even power of minus 1, odd power of minus 1, even power, odd power, even power, odd power, means you are getting minus plus, minus plus, minus plus, okay. In this way you can say here, you can write this is positive 15, this is 0, negative 0, so this would be positive, the same answer would be, okay. Now odd power of minus 1, it would be negative, negative and negative 6, it will be positive. Again even power minus 3, same here, odd power 0, even power same, odd power, so even power the same, okay. So this is actually the cofactor. So cofactor, I hope you have understood the answer. I am going to check it. 15 0 minus 10, 6 minus 3 0 minus 15 0 5. Yes, it is okay, good, all right. So in this way you can also find adjoint. So what would you do for the adjoint? This is the cofactor, just take the transpose of this, you would get the adjoint, okay. So this is your C, okay. So you have, this is C, okay, C equal to, and if you want to find the adjoint, so adjoint would be, adjoint of A would be transpose of this cofactor, okay. So row 1 will become column 1, 15 0 minus 10, row 2 will become column 2, in 6 minus 3 0, 6 minus 3 0, row 3 will become minus column 3 minus 15 0 5, minus 15 0 5. So in this way you can find the adjoint of matrix, okay. So let's move to the next question. here we should know also the properties of adjoint. Okay, so the first property is adjoint of A into A. Okay, it should be small letter, into A, and A into adjoint of A is equal to determinant of A into IN. Okay, identity matrix. So it is the one of the rule. Okay, second is adjoint of A equal to determinant of A raised to power n minus 1. Okay, and here here A should be non-singular, means determinant of A should be not equal, should not be equal to 0. And third is adjoint of AB, like this, adjoint of AB, so you can distribute it like this, adjoint of A and adjoint of B, like this. Okay, fourth is suppose if determinant of A is 0. Okay, this is singular matrix, so adjoint of A into A and adjoint of A into adjoint of A will be equal to 0. Okay, now fifth one is adjoint of A, this one is very important, equal to determinant of A raised to power n minus 2 into A. Okay, you can find the similarity, power. Okay, you need to learn this. And here is also a condition that where A should be non-singular, that means determinant of A should not be equal to 0. Fifth, sixth. Okay, here sixth is adjoint of A transpose. Okay, adjoint of A transpose, you can write it like this, adjoint of A whole transpose. Okay, seventh, adjoint of a diagonal matrix is diagonal matrix, so you need to remember it. Determinant of adjoint of A. Okay, adjoint of, if you take the determinant of this adjoint of A ka determinant, then it would be determinant of A raised to power n minus 2 whole square. All right. Next one, the eighth is what is this eighth one? Adjoint A raised to power m. Okay, like this. So you can write it like adjoint A whole raised to power m. I think, yes, it is. Here m belongs to natural number. Okay, keep this in mind. Adjoint of identity matrix is the identity matrix, and adjoint of zero matrix is zero matrix. Okay, learn it. So now move to the next question, next topic, whatever you say. So the next topic is, I think, inverse of matrix. Yes, inverse of matrix, how a matrix is invertible. Okay, so two matrices of same order, suppose two matrices of same order, and should be square, two square matrices of same order. Okay, suppose A and B are two matrices of order n. Okay, A and B are two matrices of order n. So, and AB equal to BA equal to, if you see, I. Okay, and since A and B are two square matrices of same order n, so you get, if you get IN, identity matrix, then in this case you can say that B is the inverse of A, and you can write it as A inverse equal to B. If it is this, then A is invertible. Second case, okay, second case, if determinant of A is non-singular, then you can find the inverse by using the formula A inverse equal to, okay, adjoint A upon determinant A. Okay, this is also the formula. Keep this in mind. Now there are also the properties of inverse. Okay, so here properties are, first property, if you know, A, B, C are three matrices of same order. Okay, matrices of same order, and order n, suppose. Okay, then there is a property, and they are non-singular. The most important thing, that means A, determinant of H is not equal to 0, determinant of B is not equal to 0, and determinant of C is also not equal to 0. Then we have the property AB equal to AC, then A and A can be cancelled, then B equal to C. This is called left cancellation. And if it is BA equal to CA, so AA can be cancelled, so you will get here B equal to C. This is called right cancellation. Okay, right cancellation. Third property is AB inverse equal to B inverse A inverse. If you write AB inverse equal to A inverse B inverse, then you know that matrix multiplication is not commutative, so AB is not equal to B in this case, so you need to learn this. Similarly, A, B, C whole inverse, then it would be equal to C inverse into B inverse into A inverse. Alright, the fifth one is, if you take the transpose and take the inverse, if you find the inverse inverse of A transpose, then it would be like this, A inverse transpose. This is possible. Okay, sixth is KA inverse equal to 1 upon KA inverse. Okay, if K is not equal to 0. And the last, the eighth one is determinant of A inverse, okay, is equal to determinant of A power minus 1. If it is this, then okay, this is, then A inverse would be, or can be written like this. Okay, this is the property. Okay, let's move to the question. How would you find the inverse, and how you can find the adjoint in a quick way? So if we first learn how you can find the adjoint of 2 cross 2 matrix. Okay, adjoint. A is, suppose, A11, A12, A21, A22. So if you want to find the inverse, then it should be non-singular. Then determinant of A, how would you find? A11, A21, A12, A22. How? Left cross minus right cross. Okay, A11 into A22 minus A21 into A12. Alright, and A adjoint of A, how would you find? The adjoint of this matrix, 2 cross 2 matrix, you can find in a quick way. Like, how would you? You need to exchange this and change the sign. This is left diagonal. Okay, this is called left diagonal, this is called right diagonal. The left, exchange the left diagonal. That means this A11 become A22 here. Okay, A22 and A22 become here A11. This is called exchange the left diagonal and interchange the sign of or of the right diagonal, only sign. Okay, so this is plus, so it will become negative of A21. It is positive of A12, so it will become negative of A12. Is it all right or not? I think, yeah. Yes, it is. So now what is A inverse? A inverse is adjoint A upon determinant of A. So determinant is A11 A22 minus A21 A12, and your adjoint is okay A22 minus A21 minus A12 and A11. Okay, learn this only. What about, so this is the direct method of solving adjoint of 2 cross 2 matrix. Now let's take an example and solve with, okay, here if 2a equal to 2 3 1 2, then find A inverse. Okay, so here's the question. Now what do you have to do? First you have to find what A would be like this. What if you divide both sides by 2, this 2 will be eliminated, so it will become 1 by 2 2 3 1 2. Okay, move 2 inside, 1 by 2 inside, so you know that 1 by 2 will go with every element here. Okay, in the matrix. Okay, in the matrix 1 by 2 will go with every element, so 1 by 2 into 2 it would be 1, 1 by 2 into 1 it would be 1 by 2, 1 by 2 into 3 it would be 3 by 2, 1 by 2 into 2 it would be 1. Okay, you found what A inverse. Now you need to you have to find A inverse. So A should be non-singular, so find determinant of A. So left cross minus right cross, A 1 3 by 2 1 by 2 1, left cross minus right cross, like 1 minus 3 by 2 into 1 by 2, 3 by 2 into 1 by 2, it would be 1 minus 3 by 8. Okay, sorry, this is 3 by 1 by 2, 3 by 4, so it would be 1 by 4. Alright, so here you see determinant is not equal to 0, so it is non-singular. Then in this the A inverse is possible, so find adjoint, and I have told you how to find adjoint. So you have to change this exchange what is this, yeah, exchange the left diagonal and change the sign of right diagonal. So left diagonal is this. Okay, this is the left diagonal. Where is A? Yeah, this one is A. So change the left diagonal, that means one will go, that means change that exchange, one will go here and this one will go here. Okay, so 1 and 1, so and change the sign of the right diagonal. Sign of it is positive, this is also positive, and then they will become negative, minus 3 by 2 and minus 1 by 2. So alright, exchange the left diagonal and change the sign of the right diagonal. I have done this. Now according to the formula of A inverse, what is this? Adjoint A upon determinant of A. And what is determinant? 1 upon 1 by 4 of adjoint is 1 minus 3 by 2 minus 1 by 2 and 1. And when you move, okay, 1 upon 4 would be 4, 1 minus 1 by 2 minus 3 by 2 and 1. Okay, and here you can move 4 inside to with all the elements. Okay, then you will get the answer. Let's move to the next question here. if A equal to 3, 2, 0, minus 3, minus 1, 4, 4, 1, then find adjoint of A. Oh my god. So this is very lengthy. No, we have to use the property. And what is the property? Adjoint of A equal to A raised to power n minus 1 into A, I think. I have to check it out. No, it is n minus 2 into A. So you have to learn this. But there is a condition where determinant of A should be not equal to 0. Yes, this is the property. So it is, I think, which property is this? Yes, this one is the property. Now we have to use this. So first solve determinant of A. Okay, so 3, 2, 0, minus 3, minus 3, minus 1, 4, 4, 1. How do you find the determinant? This you have to write here positive, negative, and positive. All right. So first start with positive 3, plus 3. Okay. Then here minus 3, negative of negative 3, and positive of, then make 2 cross 2 like determinant here. Okay. Plus 4. Make again 2 cross 2 determinant. So what would you fill here? You would fill, that means whatever you choose, leave that row and that column. Okay, you have chosen this 3, leave this row and this column. So what would you get? Minus 3, minus 1, 4, 1. So right here, minus 3, minus 1, 4, 1. Now you have chosen this minus 3. So leave this row and this column. What would you get? 2, 0, 4, 1. 2, 0, 4, 1. Okay. Plus 4. Leave this row and this column. Okay. This row and this column, because you have chosen what? Plus 4 here. So what would you get? 2, 0, minus 3, minus 1. 2, 0, minus 3, minus 1. Okay. So solve it. 3. How would you solve this determinant of 2 cross 2 matrix? So here left cross minus right cross. 1 into minus 3 would become minus 3. Minus of minus 1 into 4, it become minus 4. Okay. Minus of minus 3 plus 3. Left cross minus right cross. 1 into 2, 2. Minus 4 into 0, 0. Plus 4, left cross minus right cross, it will become minus 2, minus 0. Okay. So 3, minus 3 plus 4, it is 1, plus 3 into 2, plus 4 into minus 2, again 3, plus 6, plus minus 4 to the 8, 3 plus 6 plus 3, 9 minus 8, 1. And determinant here you get not equal to 0. All right. So now you can use here. Okay. So you get determinant equal to, note it down, determinant equal to 1. So use the value here. So you need to find adjoint of A. Then it would be A, determinant of value of determinant is 1 is to power n minus 2 into what is A? You have A. Okay. So it would be 1. So don't write 1. The answer would be A. So adjoint of A is equal to, in this case, A, the matrix itself. Okay. The last question is find the matrix of, inverse of 3 cross 3 matrix. Find the inverse of 3 cross 3 matrix, and the matrix is what? 0, 1, 3, 1, 2, 1, 2, 3, 1. All right. If you want to find the inverse of this matrix, and this has order 3, it is a square matrix of order 3. All right. First find the determinant. How would you find it? So you have to write again like this: 0, 1, 3, 1, 2, 1, 2, 3, 1. How would you solve this? You have to identify first positive, negative, then here positive. First you write positive 0, then make 2 cross 2 determinant. Okay, so negative 1, make 2 cross 2 here, plus 2 here, plus 2, and again 2 cross 2. Okay, and what would you write here? You have chosen plus 0 here. Remove first row and first column. That remove that row and that column. What would you get? 2, 1, 3, 1. Write it. 2, 1, 3, 1. You have chosen here minus 1. Remove that row and that column. What would you get? 1, 3, 3, 1. 1, 3, 3, 1. Plus 2. Remove that row and that column. You will get 1, 3, 2, 1. 1, 3, 2, 1. Solve it now. 0 will be multiplied by left cross minus right cross. It will be 1 into 2. 2 minus 3 minus 1. Left cross minus right cross. 1 minus 9. Okay, plus 2. Left cross minus right cross. 1 minus 6. Alright. 0 minus 1 minus 9 minus 8. It will be plus 8 plus 2 into 1 minus 5, 1 minus 6 minus 5, minus 5 into 2, it will be minus 10. So 8 minus 10 would become minus 2. So it is not equal to 0. That means this is non-singular matrix. Okay. Now you need to find. So we can write here that determinant of A is not equal. It's minus 2. Determinant of A here is equal to minus 2, which is not equal to 0. Okay, now you need to find what? The cofactor. Okay, so C, the cofactor would be C11, C12, C13, C21, C22, C23, C31, C32, C33. All right. So how would you find this? You need to first find C11, and C11 would be here minus 1 raised to power 1 plus 1 M11. C12 would be minus 1 raised to power 1 plus 2 M12. C13 would be minus 1 raised to power 1 plus 3 M13. What is C21? Minus 1 raised to power 2 plus 1 M21. C22 again minus 1 raised to power 2 plus 2 M22. And C23 is minus 1 raised to power 2 plus 3 M23. I've explained this earlier. So how would you find M11? So M11 is actually, how would you find? By removing first row and first column, and you find the determinant of submatrix. Okay, by removing first row and first column. Here 2, 1, 3, 1, 2, 1, 3, 1. This is M11. Okay, 2, 1, 3, 1. This is M11 here. So how would you find M12? M12 would be the submatrix of removing first row and second column. It would be 1, 3, 3, 1. 1, 3, 3, 1. In this way you can solve it. You can find, suppose if you want to find C32. Okay, suppose 3, 3, 2. How would you find? Minus 1 raised to power 3 plus 2 M12. M32. So what is M32? It would be minus 1 raised to power 3 plus 2 minus 1 raised to power odd number. The answer would be minus 1. What is M32? It would be determinant of submatrix. Okay, submatrix by removing third row and second column. Third row and second column. Third row and second column. It would be 0, 1 and 2, 3. 0 1 and 2 3. Solve it. Minus 1 3 when there is a 0 minus 1 to the 2. The answer is here 2. So I'm going to write here the cofactors I have found. It is minus 1 1 minus 1 8 minus 6 2 minus 5 3 minus 1. Okay, this is the cofactor. And when you solve, okay, these are the cofactors, and you need to find what? The inverse. Okay, so it is non-singular matrix, it is invertible. You have found here the cofactor. So adjoint of A would be, how would you find adjoint? Adjoint of it would be transpose of cofactor. Take the transpose. Okay, transpose, that means row 1 will become here column 1, like minus 1 8 minus 5. Row 2 will become column 2 1 minus 6 3 1 minus 6 3. Row 3 will become column 3 minus 1 2 minus 1 minus 1 2 minus 1. Okay, and you know that what is A inverse is adjoint A upon determinant of A. All right, so here determinant of A is minus 2. So A inverse, in A inverse, what would be 1 upon minus 2, like this. Okay, minus 1 1, same here, this value, and minus you can shift inside minus, and 1 minus 1 8 minus 6 2 minus 5 3 minus 1, and you can shift minus here and you will get the value. Thank you very much. Thank you for watching this video. Thank you.